Good morning. Welcome to this morning's webinar. It's Mike Lees here, Product Manager, as usual joined by Ed Stanier. Morning, Ed.
Morning, Mike. Morning, everyone.
So let's crack straight in. So today's agenda, a little bit of background. I think most of you are fairly regular now, so I've cut this down a little bit in terms of the background. I think you know where we're coming from. There is a bit of a different change to the agenda format today. Thanks for all the feedback on the last webinar particularly. Ed, I felt that we skipped over some fairly big topics. I mean, nobody complained, but, you know, I wasn't totally confident. Things like VLAN, spanning tree, subnetting, probably didn't do them justice. What do you think?
Yeah, agreed. I mean, they're very big topics, so it's hard to cram everything in within half an hour.
Yeah. So with that in mind, what we've done for the security session is split it over three sessions so we can do it justice. I want to try and keep the webinars to a reasonable length, half an hour, so we're going to do it over 3 and go into a bit more detail, and hopefully you'll get more information. And what we'll probably do then, Ed, is revisit some of the early ones and do some deeper dives.
Absolutely, yeah.
Somebody asked about doing more on subnetting, you know, VLANs, and again, spanning trees probably a subject in its own right.
Yeah, certainly.
So from a security point of view, what we do today is secure management and take a look at port security, and as usual, look at Q&A at the end. We've had, I think, probably 2 or 3 questions, but we've taken all those offline because they've been quite specific to people's applications. And, you know, we're happy to pick up those conversations. In fact, we've got a couple of visits lined up, and the message is, you know, we're happy to take things offline, more specific, that maybe aren't useful to the wider audience. And as always, you know, if there aren't any questions through the webinar, then we won't make any up. We'll close it at that point. So, just one quick slide, my favourite slide, a bit of a funny picture, and it's really just acknowledging that, you know, Ethernet, it's a really technical and in-depth subject. And one of the challenges is it can appear quite simple, the way you connect devices together just by going in and whacking into a free port, and that's what creates a lot of problems that we come across. So in terms of how we position this, you know, a lot of engineers now that are doing network maybe haven't come from a networking background, and that makes it even more challenging. So the work that we do, the training and so forth, is very much geared to training from the aspect of an OT engineer who might not be a specialist network engineer and doesn't work with networking day to day. So the webinars until today were based around our training course, which is a 3-day training course. We've actually run the course a couple of times now, Ed, so I guess we're getting more feedback in terms of what people are finding challenging, and so we can start feeding that back into the webinar.
Exactly, yeah.
So the next scheduled course is September. There's people booked on that already, and we can run courses sooner if required. So as you can see from the slide there, networking basics, networking switching, and security, that's the rough format of the course, and it's very hands-on. So again, if there's any questions on that, happy to take them. So let's crack in, Ed. So secure management. I guess here really just talking about the fundamentals of talking over a secure or non-secure network.
Yeah, basically, Mike. Yeah, the difference between the two, and on the surface, it obviously seems quite simple. One's a secure channel, one's an insecure channel. But really, it's about understanding the knock-on effects of having these insecure management, you know, protocols running on your network, running on your switches, your firewalls, that kind of thing. And on the training course, we go into quite a lot of detail as to the problem with insecure management protocols is how easily they can be exploited. And we're not talking about, you know, needing a lot of knowledge to exploit them. It's reasonably straightforward with a little bit of know-how and the correct software. They can be very easily exploited. And when I say exploited, what I mean by that is that stealing usernames and passwords, that kind of thing, management information on your switches. An insecure management protocol is essentially one that is transferred over the network in clear text, so there's no encryption or anything like that. And we have a look at just how easy it is to sniff those, so to speak.
I think we've got a slide on that, haven't we, Ed?
We do, here we go. So, nice kind of simple diagram here. On the left-hand side, we've got a standard HTTP connection. Let's assume we're just logging into a normal web server here, but equally this could be a web service on a switch or a router or a firewall or something like that. And it's just to kind of demonstrate there the potential for like a man-in-the-middle attack. So we've got that little icon of a person's head there on the left-hand side, and they're able to intercept and sniff that traffic across the wire. And actually in the training course we do like a demonstration as to just how easy it is to do that. Now as soon as we bring in a secure channel, encryption, in this case HTTPS, then what we're doing is we're setting up, you know, a point-to-point encrypted link between us and the web service, as I said before, whether it's a web server or a switch or something like that. And essentially anyone who attempts to sniff that traffic, intercept it, they will just be met with, you know, encrypted text that will mean absolutely nothing to them unless they're able to get the decryption keys. Now there are still ways that you can exploit HTTPS, but it's a lot more secure than just having, you know, plain text passwords being sent across your network. And the thing about this also is how easy it is to configure your devices to use secure channels as opposed to insecure ones. So it's not a lot of extra configuration work, but, you know, the security benefits you get from it are really quite great.
Why don't we just use HTTPS by default?
Well, I mean, some vendors do. It depends which vendor you're dealing with. Some will actually force it, and particularly on more modern hardware, it's becoming a bit more of a standard. I know there's a couple of Hirschmann firewalls that actually now enforce HTTPS connections, so you literally just don't have the ability to connect over an unsecure channel. But that's not to say that other vendors don't, and particularly on old hardware as well, it's still quite the standard. So it's something really you need to be made aware of and see where you can reconfigure it.
Just click on a bit more detail, I think. And I noticed you mentioned SSH here. Is this Telnet? Is that?
Yeah, that's right, Mike. Yeah, SSH is the secure equivalent of Telnet. And the actual kind of encryption system, you know, it's called public key cryptography. The way that it works is the same for both HTTPS and SSH. One's obviously just for web management, and one's for, you know, command line management through Telnet or SSH in this case. And this diagram it's probably the simplest way to explain how the encryption works on at least a basic level. It's a very in-depth subject, so we'll just kind of flick through it quickly now. But essentially your laptop, your computer will request a certificate from the web server or the switch or whatever it is you're connected to. The device in question will answer back with its own certificate. From there'll be some validation, some trust that you'll kind of establish with the end device. And after some exchange of keys and some kind of complicated maths in the background that this cryptography all works upon, you'll essentially have a secure channel between the two. And that means that anything then sent over the wire can only be decrypted through the use of the device's private key or your key that you generated when you first established a session. So it's preventing anyone without the decryption keys from being able to do anything with that traffic. So they can still intercept it quite easily, but actually trying to read it and understand, you know, read usernames and passwords, that kind of thing, is practically impossible. The encryption standard is extremely secure, and this is the same standard that we'd use when logging on to Google, Amazon, you know, any big website. Even online banking will use the same encryption standard. And so actually decrypting it, it's practically impossible. Given our current technology, we just can't do it. Yeah, this is just a kind of bit of a comparison really between Telnet and SSH. And these are the standard protocols you'll use to configure Cisco switches, especially in Cisco routers, Cisco firewalls. They're a lot more focused on command line configuration, and actually a lot of other vendors also offer these, but perhaps try and focus a bit more on web management. But the actual difference between the two, obviously in the table there, SSH is a lot more modern. Telnet was, originally created in the 60s, very, very old protocol, but still used today. And it's a great protocol. The only problem with it is that everything's transmitted in plain text. So when you're logging onto devices, you send in usernames and passwords, and obviously, again, just like with HTTP, they can be intercepted. So SSH overcomes that by using the same encryption we just looked at in the previous slide, and setting up that secure channel before you send anything over the wire. And the only thing really to consider with that is the additional overhead you have. The encryption will add additional traffic, it's additional processing power required by both devices to encrypt and decrypt it. Having said that, with modern hardware and with modern networks being as quick as they are, generally at least 100 meg, in most cases gigabit, the extra bandwidth isn't really an excuse not to use it. So it shouldn't really be too much of a consideration nowadays. There's very little reason not to use SSH. In fact, in my opinion, there's no reason at all not to use it as opposed to Telnet.
Okay. And you mentioned Cisco there, Ed. Yes. So Cisco versus Hirschmann. So Cisco's more oriented towards SSH, whereas I don't think Hirschmann is it? Exactly,
yeah. I think one of the key things with Hirschmann kit is ease of configuration and administration. So the way they do that is with nice, easy-to-use web interfaces. Obviously, the downside with that is that their feature set is nowhere near as rich as Cisco's. So generally speaking, with Cisco hardware, you can do a hell of a lot more. However, the actual command line of Cisco is a skill within itself. So configuring certain things on Cisco devices can be quite challenging.
Yeah. I guess that in a way positions our view of Hirschmann versus Cisco as
yes.
Hirschmann from an OT engineering point of view,
yes,
can be just the job without the complexity of the Cisco command line, but the Cisco is very functionally rich and powerful.
Exactly that.
If you know how to drive it.
Yeah, precisely.
So VLANs, obviously talked about VLANs in the last webinar session, but this is, and we talked about VLANs from a security point of view, but this is a subtly different case, isn't it? This is using VLANs for the actual management traffic.
Yeah, that's right. And by default, and again, this comes back to your contradiction of Ethernet slide. By default, if you start chucking in a bunch of managed switches, everything will be on VLAN 1, the default VLAN, and everything is kind of sent over that VLAN. It's just a flat VLAN structure, if you will. Now, a good kind of security practice is to keep your management interfaces away from your user VLANs. I mean, in this case, this picture here, ideally what we'd do is not use VLAN, excuse me, not use VLAN 1 in the first place. But if we were to keep on VLAN 1 for whatever reason, one of the quick fixes to kind of boost your security would be to take those management interfaces away from VLAN 1 and put them on their own management VLAN. If we can just move to the next slide, Mike, just to give a demonstration. All we've done here then, excuse me, is create a new VLAN, a dedicated management one, and what we can do then is we can lock down the ports and the devices that can access those management interfaces. We can control that to as many or as few ports and devices as we want. Before, on the previous slide, anyone, anywhere within the network could have potentially had access to the management interfaces. Now, that's not to say we've got usernames and passwords, but with a few kind of exploits, it's quite easy to intercept them. And again, especially if you're using insecure management protocols. So by doing this, what we're doing is we're limiting that kind of surface area of attack. If we lock down our management VLAN and only allow one port to connect to it, then that port could be connected to a workstation that's in a secure office. It's an engineering workstation or something. You're limited the amount of people who can even get onto that, and you greatly increasing your security there for your management interfaces.
Okay. So I think that's the last slide on secure management. And from the point of view they always do in terms of the OT engineer, security, so topical. This is an area that really engineers at least have an appreciation of and get into, Ed? What's your view on that?
Yeah, I mean, security it's a very big subject, and there's a lot of things to consider with it. Having said that, in most cases, from an IT engineer's point of view, obviously they may not want to get or may not have the knowledge to get involved in some of the really more advanced things, but there's some very simple and straightforward quick fixes almost they can do to start bolstering their security.
It kind of leads us nicely into port security, isn't it? I mean, it's one of the fundamentals, and almost always comes up when we're doing our initial security audits on site, and then in the follow-up actions in terms of tidying up the site, it's security 101, if you like.
Exactly, yeah. I think a lot of people, when they think security, they think, right, we've got to get a firewall in, we've got to protect ourselves from the internet, and, obviously all these stories of ransomware and whatnot going on at the moment. But a lot of attacks will come from within, and if you haven't secured your local networks, your access layer, then that's probably one of the first things you want to be focusing on. And it's probably also one of the perhaps easiest ones as well. It just requires a little bit of thought as to what things you want to allow and what ports you need open and that kind of thing. So, yeah, port security is kind of focuses on almost the access layer, all your switches, and really it's about managing those, locking them down as you need them, and restricting them in certain ways. So this is just kind of some of the best practices, and just a nice, easy 5 points. And some of these are perhaps a little bit harder than others, but I mean, let's start at the top. The first one: reconfigure all unused ports to a different unused VLAN than VLAN 1, and then disable them. So that's basically saying that we want to avoid the use of VLAN 1 if we can. Now, sometimes in older networks, everything's been configured, everything's working, and it's on VLAN 1, and retrofitting or retro-changing that is quite a big job, and it's not always practical. But if we were to configure a network from scratch, we wouldn't use VLAN 1. We'd decide which ports are connecting to which devices, and then the ones we aren't using, we would reconfigure those to a dead VLAN, if you will, a dummy VLAN, one that isn't used by anything, and then we'd disable them. It's kind of a bit of a double whammy. No one can come in and connect because it's disabled, and if they are accidentally enabled and someone does come in and connect, then they're on a VLAN where nothing else resides. They've got no routes out to the VLANs, they can't sniff any traffic, there's just nothing on there, it's like a black hole. The second one, these are spanning tree features. Spanning tree is great, and it's the industry standard for having a redundant switch network and preventing loops and that kind of thing. The problem with it is there's not a lot of authentication, validation. In fact, there's practically none. So exploiting it is actually quite easy if you understand the protocol. And there are certain features we can put on our switch ports to prevent this kind of thing from happening.
And I think I'll put a slide in later on, actually, on that subject, so we can cover that one later.
We'll cover that, yeah, okay. I won't talk too much about that right now, then. So the third point, static MAC address allocations. This can add a fair bit of administrative overhead, but it does really add an extra big layer of security, and it's to kind of lock down your ports so only certain devices can connect through them. We'll come into more detail on that in a bit there. I think we've got a slide for that. We've then got point number 4, DHCP snooping and Arp inspection. We cover this quite heavily on day 3 of a training course, but these are 2 quite common attacks that you may see in a switch network within a LAN. And these are 2 features that some vendors support. Cisco definitely support these, other vendors may or may not. But these are to kind of prevent those attacks. And just really quickly, those are DHCP snooping is to prevent a rogue DHCP server from operating on the network, and Arp inspection is to prevent man-in-the-middle attacks on kind of layer 2. And then for really high-level security, and this perhaps may be a bit out of scope for most people, but it's good to consider. is port authentication, and this is essentially when a user connects to a port, they have to authenticate before they can actually use it. So we'd use like an external radius server or something like that. Perhaps not the most commonly used thing within OT networks, perhaps more on the user side, but it's good to understand how it works and that it is an option there if you need it.
Okay, so you touched on MAC address thing, and I've always discounted this because I thought it was just loads of work and very manual.
Yes, it can be very manual. The basic idea is that you lock a port down to X number of MAC addresses, 1, 2, 3, however many you want, depending what's connected to it. Now, obviously, you can already see the extra overhead there. You're going to have to start writing down MAC addresses and configuring them. Cisco do have some nice little features that make it a lot easier and make it a lot more dynamic. I think one of them is called sticky MAC addresses, where essentially the first device that you plug into the port after configuring it will be assumed to be, the genuine device. So you don't have to go around recording MAC addresses, putting them all in.
Like a learning mode.
Like a learning mode, exactly, yeah. And there's ways you can kind of tweak that. If you had 2 or 3 devices being used there, you could plug them all in, and you can tell it to learn up to, 3, 4, 5, however many MAC addresses you want. So in the Cisco world, there's ways of making this a lot easier, and it is a really good layer of security. It just needs a little bit of thought and consideration before actually doing it. So this is our spanning tree security feature, BPDU guard. BPDU stands for Bridging Protocol Data Unit, and this is these are like the frames that spanning tree switches will send to each other to communicate and to keep track of a topology and that kind of thing. The problem there is if you've got an access port and someone comes along and plugs in a rogue switch that has a really low priority and attempts to almost take over the spanning tree topology, without BPDU guard, you've got nothing in place to stop that from happening. And if you were to do an attack similar to this, you could kind of render a network almost unusable. You could force a lot of topology changes and reconvergences, and your network will just be a mess, and you may never be able to communicate on it until you've rectified the problem. And obviously that means no traffic passing from switch to switch. It can be an absolute nightmare. What this does is if it detects a BPDU from your rogue switch, it will shut that port down straight away, stop it from propagating around the network, and that port has to be manually re-enabled then for it to come back up. So generally you'd configure this on every single access port, every non-uplink port that goes to another switch, you'd configure this on. There's no real reason not to.
And it's a familiar question for me. Why isn't this enabled by default? Is it to do with spanning tree being quite old and therefore compatibility?
Kind of. I mean, that's one of the reasons. I think when spanning tree was designed, it didn't really have any validation authentication in mind, really. The reasons behind that, I'm not too sure. I can only speculate. They wanted to keep it nice and simple, and there was that kind of level of trust already. Obviously, that's not the case nowadays. And generally speaking, I mean, some Cisco switches will have this enabled by default, but they're more small business switches that are based, for the office. Your kind of industrial range, catalyst range may or may not. It varies from model to model. And to be honest, there's some vendors, I can't quite comment on Hirschmann, I'm not too sure, but some vendors may not even support this. I know for a fact Cisco do, some may or may not.
You're saying you should go around switch by switch and enable this. And I think you've got a final slide, Ed, just going into a bit more detail.
Okay. This is a little bit technical, but yeah, this is another spanning tree security feature, root guard. So what this does is when you have your master switch and your spanning tree topology, your root bridge, by enabling this on your uplink ports, you are preventing anyone from being able to become the new root master. So again, with spanning tree, there's little validation, and it's all based on basically one number configured on your switch, which is your priority. And the lower the priority, the better. If we were to plug our rogue switch in with a really low priority, then there's no further questions asked by spanning tree. If it sees a low priority, it says, yeah, you're the new master. And obviously that can cause a lot of problems. So this enforces your topology. If your topology is configured, fixed, you're not planning on ever changing it, or at least not for a long time, you'd configure this to stop even an accidental plugging in of a switch or low priority can cause problems. So this is a good security thing, but it's also a good kind of user error thing as well. It'll stop someone from accidentally plugging an old switch with a low priority configured and becoming a new master and causing convergences on your network.
Okay, thanks, Ed. Okay. So finally, just a quick chat about what's coming up next. So when we looked at the day 3 agenda, we split it into 3 areas. Obviously, the today one, you thought access control lists and firewalls went together?
Yeah, I think they kind of go hand in hand. I mean, they're kind of core functionality of a firewall, really, having access control lists in. Obviously, firewalls offer a lot more features, and a lot of these we'll go through, you know, on the training course on day 3. But really, those two can be grouped together quite logically, so it makes sense to have a webinar on those.
And then a final session on common vulnerabilities.
Yeah, so we'll go into some more technical detail as to some of the things we've talked about earlier, but we'll look at, you know, some of the most common attacks you may have on a local area network, and maybe like a brief explanation and kind of a demonstration almost of how we do those.
Yeah, and I suspect we'll revisit security. Well, I know we'll have to revisit security at some point in the future. Yeah. And actually, the other subjects we go back to, like VLANs and things, there's always a security angle for those type of things as well.
Absolutely, yeah, yeah.
Okay, that's great. Thanks very much. So hopefully you've enjoyed the format today. It felt better to me, Ed, in terms of going into a bit more detail and not just glossing over things and
definitely, yeah,
giving a bit more useful information, but hopefully without going too deep and blowing people's minds.
Yes, yes.
I think I said right back at the first webinar that, you know, we're not going to become networking experts by attending a half-hour webinar once a month, but what we're trying to do is give pointers to people so they can go away and do more learning. And I know people do contact us out of these for asking some extra help, and that's obviously no problem at all. I don't believe any questions have come in, so that's fine, it's no problems. As ever, feel free to pop over some questions afterwards. In terms of more information, a lot of you do download the webinars and distribute them internally. That's great to hear. As ever, if you've got ideas for future webinars, you know, we'd like to get those ideas as well. In terms of why we're doing this, obviously it's fun to talk about network and security. It's what we do. We are a business. This is what we do as a business. So we're obviously looking to talk to you about consultancy opportunities. We're probably running 2 or 3 network audits a month now, I would say, Ed.
Yeah.
That's pretty static, and that means typically going on site 1 or 2 days and then doing a quick report and then following with some actions. The training Ed's mentioned, and of course we are suppliers of both Cisco and Hirschmann equipment, and happy to get involved in designing networks from that aspect. So just remains for me to say thanks very much, Ed, for your time. I hope everyone's enjoyed it, and we'll see you again in access control lists and firewalls today. So we may just go a little bit over 30 minutes today. Usual format, questions at the end. Thanks for sending the questions through. Most of the questions you're sending are specific to your application, so we take those offline. And, you know, we've started visiting a few sites, helping out for a couple of hours. If you can be flexible on when that visit's required, we can usually do that on a pre-sales basis. There has been a good question submitted today, which we will cover at the end. So on the firewalls, Ed, are we just talking hardware for the firewalls?
I think mostly hardware, yeah. We do touch upon the fact that we can get software firewalls, but I think for most intents and purposes, we're looking at hardware.
Okay. So cutting it brief today, you'll be familiar with this slide, the contradiction that's Ethernet. It's obviously we acknowledge just how tough Ethernet is as a subject, but I'd like to mention today, because we're really starting to build on some of the knowledge that we've got on earlier webinars, and I'm conscious that there's new people joining us all the time, Ed, you know, so I guess the answer to that is, as I said, the subject is complex. People can go back and look at the early webinars. They can call us for help, of course, at any time.
Absolutely, yeah.
But the language we'll be using today just build on some of the earlier things. We'll be talking about, you know, OSI models, MAC addresses, VLANs, and things. And,
exactly, yeah.
And there's no way around that, really, is there?
There's not. No, it's just that little bit of prerequisite knowledge. I think if you've got that, you'll get the most out of these webinars, really.
Okay. We do really try and position the material, though, from an OT engineer in mind, and we'll try and stay true to that. There's lots of videos and webinars online that people can watch about ACLs and firewalls, but yeah, this is really always about our world, if you like.
Yes.
So just to remind ourselves about how we structure the webinars, I put a little circle around it today just to make it a little bit clearer. So as we said before, the webinars are loosely structured around our 3-day training course. We're on day 3 now, and we've split the security down into 3 different webinars. So today, as I said, access control lists and firewalls, and next time, vulnerabilities, and so forth. When we finish going through this, Ed, I think the plan is to then do some deeper dives on certain subjects.
Absolutely, yeah. Go a little bit more in depth in perhaps some of the stuff we went through before. And yeah, I mean, there's a lot of new topics, a lot of stuff we can cover here. So it'd be nice to also perhaps get some requests if people are interested in.
Yeah, the kind of things that people sent through so far is maybe more on addressing.
Yeah, that kind of thing.
That's the favourite, because engineers don't do a lot of addressing, and that's the one that catches most people out, I would say, the addressing and things like setting up subnet masks.
Yes, that kind of thing.
And so forth.
Yeah. So,
access control lists. We talk a lot about demarcation between IT and OT, and access control lists, they are pretty tricky, and I guess they would tend to be within the IT domain. Would you say, Ed?
Yeah, a lot of the time, yeah, you will find them there, but they're becoming, I suppose, more common in OT networks as well, given the fact that security is such a hot topic and an important thing to consider in your OT network. And ACLs are really, you know, the most fundamental and basic way of protecting a network. So they're very important, at least even just to understand the concepts and understand how they work and what they can offer you. Perhaps you don't necessarily need to go down to the level of detail where you can start configuring super advanced ones, but just understanding how they work and where they fit within a network kind of security model.
Okay. A lot of the early work we do with customers in terms of securing networks, the quick fixes that we call it, it's quite often things like setting up VLANs, but also setting up ACLs, because these are what I call soft things, where you don't need always to have extra bits of hardware. You can just configure what you've got. So
that's right, yeah, and that's the good thing with ACLs nowadays, is that a lot of devices offer them. Most managed switches as well, even layer 2 ones. You don't have as much flexibility as you would with you know, a layer 3 switch or a firewall, but it's becoming a very common and standard feature on managed hardware. So yeah, definitely worthwhile understanding how they work and where we can apply them.
Okay. You mentioned about layer 2 devices there, and you're talking about layer 3 devices.
Absolutely, yeah. So pretty much any managed switch nowadays will offer some basic access control list functionality. The thing to remember is on layer 2 switches, your basic layer 2 managed switches, most likely you'll only be able to configure ACLs based on MAC addresses, because that's all we're concerned with at layer 2. So they're not quite as common because they're a little bit more fiddly, they're not as flexible, a little bit more administrative work going into creating ACLs based on MAC addresses. MAC addresses are quite, you know, awkward to deal with, so you won't see them as often at layer 2, but it's good to know that we can have them. If we want to protect devices within the same network, we can do that with layer 2 ACLs. But most commonly we'll have them on layer 3 switches, routers, firewalls, anything that kind of acts as a default gateway for clients. That's the most common scenario where you'll find an ACL configured. So just to go through these points here, we'll configure an ACL first, and then we have to apply it to an interface and a direction. So what that means is we create our rule list first, and then we have to decide where we actually want to put that on our device. You can imagine a layer 3 switch or you know, a multi-port router or something like that. We're going to have lots of connections there, lots of interfaces being used. So we have to apply that ACL to an actual interface itself. And we also need to specify whether we're monitoring and inspecting traffic coming into the interface or going out of it. So there's a bit of planning that's involved into that, because writing the ACL is one thing, putting it in the most efficient part of a network and obviously getting the direction right is quite important to A, make sure your ACL is, you know, running in the most efficient way, and also more importantly B, to make sure that you're either not inadvertently breaking other connectivity and also that you're actually protecting it where you should be and not putting it somewhere where it's not going to be doing anything and it was a kind of, you know, waste of time writing the ACL in the first place. So generally speaking, and this is applicable mainly in the Cisco world, we have basic and advanced ACLs. Basic ones only allow us to filter based on the source address, whether that's an IP address or a MAC address. We could also do it based on an entire network, a source IP network, but the important thing to remember is it's only on the source address. So a basic ACL in the Cisco world, we cannot filter by the destination address, we can't filter by protocol port, that kind of thing. So they are very basic, which is obviously good in that they're easy to administer. There's potentially less to go wrong, but obviously they're not as flexible. We're limited as to what we can do with them. And obviously, the opposite of the basic ones, we've got the advanced or the extended ones, as they're called in the Cisco world, and with them we can filter on absolutely everything. So source address, destination addresses, protocols, port numbers, you know, there's no real limit as to what we can filter on. So obviously advanced ones are a way to go if you want total control, total flexibility. They obviously do occur that, you know, extra design required and a little bit more thought into where they need to go.
Okay. I guess most ACLs that people are going to find configured, they will be of the advanced type rather than the basic.
Most likely, yeah, and some vendors won't even have this concept of basic and advanced. I think Hirschmann, for example, you're just given, you know, the ability to put in an ACL, and by default you'll get all the options of an advanced one that you would in the Cisco world. So some vendors follow this, others don't, and obviously Cisco and Hirschmann are the two big different ones here. So just some more kind of basics, more best practices, I suppose, for ACLs. So the ACL will work on the concept of you'll have a bunch of rules that have been configured in there, and when a packet comes in, that ACL is processed in order. So the packet comes in, we inspect it, we look at the first rule of the ACL, we see if it's a match or not. If it's not, we go to the next one, and we keep doing that until we find a match. If we find a match, then we either permit or deny, depending on what we've written in the rule, and at that point, the ACL is no longer processed. So once there's a match, that's it. The ACL's no longer processed, no more rules are applied, we've already decided what we're doing with the packet. So the important thing to remember about is, this really is applicable to all vendors. It's just the basic design of how ACLs work, but at the end of your set of rules, you'll have an implicit deny all rule. So it's like an invisible rule at the end of your rules that says, right, drop the packet. So if there hasn't been a match, if you've written your ACL, packets come in, there's no match on any of the rules you've written, by default that will just get dropped at the end.
So we could lose traffic that we want if we don't get it right.
Exactly. So that is such an important thing to remember, that if there is no match, that packet will get dropped unless you say otherwise. So we can work our way around that by creating a rule at the very end to say allow everything, and then we don't have to worry about this implicit denial rule. But it depends a lot on how you're creating your ACLs. There's kind of two ways you can do them. You can say, I want to deny specific things but allow everything else, and then you'd have your allow all rule at the bottom. Or you might say, well, I only want to allow these specific, you know, sets of traffic, and let's drop everything else at the end. So there's kind of two ways to do them, depending on how much security you want and that kind of thing. And really, there's no right or wrong way. It's just understanding how they work and ensuring that you've written them correctly. So moving on from that, some vendors, and I know Cisco do this, I think that Checkpoint do this as well, and probably a lot of others, they offer kind of time of day based ACLs. So these are ACLs that only kick in certain hours of the day. And I suppose a practical use for that could be, let's say you've got an operator working on a night shift, you don't want him to be able to, you know, browse the internet, that kind of thing. We could put in an ACL after 5 p.m. or whenever his shift is to, you know, deny outgoing traffic. That's just a basic example of where we might use a time of day based ACL. The next point is probably one of the most important ones, but also a little bit tricky to sometimes get your head around, and I know it took me a while. And this is what they kind of teach you in the Cisco world, mainly because they have this clear difference between basic and advanced ACLs. But essentially, they say that basic ACLs should be put should be applied as close to the destination as possible. So if you remember with basic ACLs, we can only filter based on the source address. That's all we've got to go on. So the reason we want to put them as close to the destination as possible is we don't want to inadvertently deny traffic to other, legitimate parts of the network, but we want to allow that source too. So if we were to apply that rule too close to the source, we would deny the source from communicating with anything, and that's obviously not what we want to do. We may just want one network to not be able to talk to a SCADA LAN or a server LAN that houses a lot of critical servers. So we'd put that as close to that server network as possible. Advanced, on the other hand, because we can filter based on absolutely anything, port numbers, destination, IP addresses and networks, that kind of thing, then ideally what we want to do is have that as close to the source as possible to stop us from wasting resources on a switch. And what I mean by that is, if we've already decided, right, we'll write this advanced ACL and we want to deny traffic to a certain destination address based on a port number, maybe we're stopping a bunch of engineering workstations from accessing a SQL server, something really critical. We don't want to put that close to the destination, because what will happen is, although it will work just as well as placing it close to the source, what we're inadvertently doing is wasting resources on the switch. So the switch is inspecting the packet, there's no ACL applied to the incoming interface, it's switching it or routing it to the other interface and dropping it then. So we've wasted resources on the switch, processing the packet, which it should have dropped in the first place anyway. And that's kind of where this rule of thumb comes into the difference between the basic and the advanced ones.
I think you said on the training course, this takes a bit of explaining people to get their head around, but it's a great rule of thumb, isn't it?
Absolutely, yeah. Just to make your security rules as efficient as they can be, really.
I think we've got some examples now.
Okay, so here's an example, a basic one. And this syntax in this box underneath is how it would look in the Cisco world. So this is the command line Cisco rules for an ACL. So obviously on a Hirschmann switch or something like that, you'd perhaps have a nice GUI and you wouldn't have to worry about all these commands. So don't let them put you off too much. I'll just briefly explain what's going on here. We've just written a very basic ACL with a single rule. So we've said access list number 1. We want to permit the IP address 10.10.1.100. And that is PC1 on the left-hand side there. And we are applying that to the GI0/3 interface, which is the interface connected to the server LAN, where you can see that web server on the right-hand side. So what we're essentially doing there is saying, right, PC1, we're allowing that to talk to the web server. Now, if PC2 is attempting to connect to the web server, they would get denied because of this implicit denial rule at the end. So you can see that it's not actually there in the syntax and we can't see it. We just have to remember that it's there. It's always there unless we say otherwise. So that's as basic as an ACL can really get. We're permitting a single IP address and applying it to one interface. We're saying, yeah, allow this one through, and because of the denial rule, anything else is denied. Okay, so this one, very similar to before, except instead of just allowing one PC, let's say we wanted to allow an entire network, an entire LAN. In this case, we're saying it's an engineering LAN, so it's a trusted LAN. We know the devices we've got on there. We know the users using it. We want to trust that entire engineering LAN to talk to the web server. So essentially, we've just used these wildcards. Now, these differ from vendor to vendor. So there's no kind of fixed rule with these, and all it's basically doing is representing an entire network as opposed to a single device. So here we've said 10.10.1.0, and we've actually got a reverse subnet mask.
Like a subnet mask, but
it flips over, exactly. I do have an answer as to why Cisco did that. I just can't remember it off the top of my head. And to be honest, it doesn't help. It doesn't make it any easier to learn ACLs in the Cisco world, because this kind of goes against what you'll have previously learned with subnet masking and that kind of thing. With that being said, other vendors, for example, Hirschmann, they might make it a little bit easier to represent a network. You'll use question marks instead. It would be 10.10.1. question mark, which says that last octet can be anything. representing that entire subnet. So it makes it a little bit easier. But essentially, that's what we're doing with this ACL. We're saying, right, permit that entire LAN, and once again, because of the denial rule at the bottom, PC2 still can't touch a web server.
Right, that looks a bit hairy to me.
This one is a bit scary, and yeah, so try not to get too concerned with the CLI stuff at the bottom. So in this example, we've got PC2. And PC2, which is 10.10.31.100, that's in the top left corner. Those first two rules then in that rectangle there, access list 101, we want to permit TCP from, so the syntax starts with the source first, destination after. So we're saying, right, permit it from PC2, and our destination is 10.10.2.100, which is a web server. And those ports, those numbers at the end, so we've got EQ80 and EQ443, they're the standard HTTP and HTTPS ports. So all we're doing there is saying, right, PC2 can talk to the web server over HTTP or HTTPS. And we're applying that then as close to the source as possible. So what we've done there is we've applied it to the 0/2 interface. As soon as that packet comes in, we're looking and we're saying, right, is PC2 trying to talk to the web server? If so, allow it. If not, deny it. So this could be a very basic PC somewhere in an unsecure location. We literally want to lock it down so it can just access. It might be a reporting service, some kind of SCADA monitoring service or something. We want it to be able to view that, but nothing else. It's like a view only. So we've really locked these rules down. We're saying you can talk to the web server, you can't talk to anything else. The other thing we've done here is we've also created a second ACL to allow 10.10.1.0, and that's the engineering LAN. And we've said permit IP, which is anything. So we're essentially saying here the whole of the engineering LAN can talk to everything on the server LAN 10.10.2.0. So we've put some levels of trust in here. We're saying engineering LAN, that's fine, that can talk to everything on the web server. But this PC2 and another network, that might be in a lobby somewhere, it might be somewhere untrusted, anyone comes along and is able to access it. So we've said with that, right, that can only talk to web server, nothing else. So the syntax is a little bit scary, I do admit, but as long as the hardest part with ACL is normally understanding your requirements, knowing what you want to allow and what you don't want to allow, and if there's going to be any implications to that. Are you inadvertently going to, deny legitimate access you need somewhere? So the hardest part is mapping out what you want to allow and what you don't. The syntax is always the same, and obviously it does differ from vendor to vendor, but once you've decided on your rules, writing the syntax isn't too bad after you've done the first few. You soon understand that, how it works, how it's structured and that kind of thing.
You've got one further example.
We do have one more advanced, yeah.
What's the difference on this one, Ed, than the previous one?
So the only difference here, so if we look at the first two rules at the top are exactly the same as before. We're saying PC2 can talk to a web server. But we're also saying here that PC2 can also talk to the engineering LAN. So we want to allow PC2 to talk to web server, nothing else in the server LAN, but we also want to give it access to the engineering LAN. And maybe some devices on there it needs to talk to, that kind of thing. And the only difference that we've done at the bottom, so if we look at the second access controller, cell 102, we are denying the entire engineering LAN there, so 10.10.1.0, that's the whole of the LAN, engineering LAN. We're denying it to talk to the database server. So we're essentially saying anything in the engineering LAN cannot talk to that database server. That might be critical, it might be owned by another vendor. We might not want anyone in the engineering LAN going anywhere near that because it's got some real critical data on that they shouldn't be messing with. So we've essentially said anything from that LAN cannot talk to anything on that database server. Now, because we've done this in a slightly different way, as I said before, there's a couple of ways to write ACLs. You deny everything and allow some at the end, or you allow things you want and let the implicit rule deny at the end. What we've said here is we just want to deny it to the database server, but we've put this permit IP any rule underneath that. So that says that absolutely anything from any source to any destination is allowed. But because, as I said at the start, because of ordering of ACLs, how it works, that rule at the top takes precedence. So the first thing it will do is check if we're talking to the database server. it doesn't match that, we're allowing whatever else it may be. So it's just one single rule to deny access to a single device.
It's unlikely that anybody listening today who didn't know ACLs before, they're not going to suddenly dash off and start fighting these things.
Not, no, absolutely not.
But it's all about having the awareness of what's possible.
Exactly, yeah.
Would you agree, Ed? I mean, ACL should be a fundamental part of cybersecurity.
Absolutely, yeah, and yeah, that's right, yeah, and even basic ones, you know, you don't have to write super convoluted ACLs and create an administrative headache going forward. Even some basic ones put in the right places can help you a lot. But it really is, and as I said before, the hardest part is knowing what devices need to legitimately talk to others, and if they don't need to talk to others, then those are places where you should be putting rules in. If that has no legitimate reason to talk to another device on another network, then we should be denying that. Just kind of basic security 101, really.
Now, we come across situations on sites where the OT engineers don't own the layer 3 devices.
Yes.
So what's the implications there? By layer 3 devices, I'm implying that that's where most of these ACLs will be set up.
Generally speaking, they are, yeah. And there's a couple ways round that. There are scenarios where we may want to use a transparent firewall, which will...
Or even talk to the IT department.
I mean, yeah, you probably won't get very far, but yeah, in an ideal world, you'd have a nice discussion with the IT department, tell them what you want to implement, but in my experience...
And having an understanding of ACLs would allow you then to have that conversation.
Absolutely, yeah, that's right. I mean, if you can fully explain your requirements to them, then there's a good chance that they'll work with you and get these kind of put in. If obviously you can't do that and there's just kind of no way to modify anything on those layer 3 devices that aren't in your custody, then the good news is there are still some scenarios where we can retrofit devices kind of in transparent mode, which we'll move on to.
That wasn't meant to be a lead into the next slide, but it worked out quite well.
Very well.
I guess when people are thinking about security, they don't think ACLs, top of mind. Firewalls. Yeah.
Absolutely, yeah. But with firewalls, you know, the most common feature on a firewall is ACL, so it's good to know that, you know, they go hand in hand. So they do ACLs, and that's a core of their kind of functionality, the main role of them in the network. But they also do a lot of other things, especially nowadays. You know, IPS and IDS systems, so intrusion prevention and intrusion detection systems. So we'll have a little look at those as well. But maybe if we just start with kind of different types of firewalls and how they work. So they can come in software and hardware forms, and a lot of layer 3 devices will now offer firewall functionality, but also firewalls nowadays will offer layer 3 functionality. So it used to be that you'd have a router, you'd have a firewall, and now a lot of devices are combining these features together. So for example, in the Hirschmann world, you've got the Eagle 30, which is a router and a firewall. It does layer 3, it does ACLs, there's other firewall functionality. So it's a single device essentially to provide routing for networks and provide security.
So we've seen a blurring of the lines really. I mean, in the very first webinar we talked about this does this, this does this, but
yes. The technology is moving fast in the networking world, and yeah, now you'll have devices that can do everything. And the thing is that these devices as well will do general layer 2 switching as well. So it is becoming to the point where we're just going to be combining this functionality into, you know, a big device, one big mega device almost. I mean, we did briefly mention software before, but really that we're talking things like Windows Firewall and that kind of thing, and other, you know, Komodo software firewalls, things like that. And they have their use in certain scenarios, but really hardware firewalls, we want to protect the entire network. There might be scenarios where we need to protect individual devices, but generally speaking, we're looking at the whole picture, and that's why we want to use a hardware firewall. So they're used to protect different areas of a network, and most commonly you might see them in the DMZ zone. So you might see one after your internet connection before it hits any rest of the network, a perimeter firewall perhaps, if you will. But you can also have them further down in the network, and you can have them as low down as, you know, where your PLCs are. We can, and obviously Hirschmann offer these Tofino firewalls, which are you know, very, I say basic firewalls, but they're intended for a specific purpose to protect a small ring of devices, if you will, a small ring of PLCs. So we can have them top to bottom, but generally speaking, we will see them protecting multiple networks, and because of that, we might have them further up the chain, if you will.
A lot of the projects we've done, Ed, on the firewalls deeper down have quite often been on legacy projects.
Generally speaking, yeah.
Like you say, some XP machines.
Yes.
That the customers can't touch. They can't upgrade them, and therefore we find that firewalling is a good solution.
Absolutely, yeah.
Lower down.
Exactly, because sometimes it's just not feasible to replace legacy kit. You know, the headache and the cost and the time involved.
Earlier on, when we can't get access to the layer 3 devices.
Exactly, yeah.
We might do more firewalling, so it might alter the balance of the security.
Yes, strategy. Absolutely. I mean, it's just worth noting that it's good to plan the kind of firewall you want and where you're going to put it. And obviously, as you know, we've had scenarios where we've had firewalls that weren't up to the job. They didn't do what we wanted them to do. So it's good to understand what firewall you're looking at and the features it offers and how that's going to sit in your network. If a firewall only does rooted mode and not transparent mode, for example, and you've got no access to your layer 3 stuff, then you're not going to get anywhere. It's not going to help you at all.
I think the next slide is actually going into more detail now.
Exactly, yeah. So the rooted mode firewalls, quite simply, imagine them just as your routers. So if you've got two different networks and you had a firewall that does rooted mode, then you could just have that firewall as your default gateway for all your clients on both networks. So what that basically is doing is it's ensuring that any traffic that passes from LAN to LAN, it has to go through that firewall because that's the default gateway. There's no other way it can go through. It has to be inspected by the firewall before it decides to route that packet onto the other network. And this is quite common, really. This is one of the most common types of firewall functionality and applications you'll see for it, is using it as your default gateway for your clients. And you will see these a lot in the kind of a DMZ zone, distribution zone, somewhere a little bit higher up in the network where we're essentially, linking different networks together. This is one of the most common types of firewall, and I suppose in a way it's perhaps one of the easier ones to configure as well. We've got clear boundaries between networks. And in this scenario here, you can imagine there we might just have two interfaces, one going into LAN 1 switch, another going into LAN 2 switch. We've got a nice, easy setup there. And that's a very common scenario you'll see with a rooted mode firewall.
I'll pick up on that, because you say it's easy. Wow. When you're retrofitting.
Yes, when you're retrofitting then.
Why is retrofitting harder?
I mean, I suppose there's a couple of things. When you retrofit, if you were to retrofit a rooted mode firewall, you've got to ensure that you're configuring the interfaces exactly with the same IP address as your current default gateways. If not, you've got the big task of readdressing a load of clients. Yeah.
And if there is no default gateway, then you're adding an extra device, and then you could be faced with reconfiguring.
Yes. You could have, exactly, yeah, which can be a real nightmare when you've got PLCs, workstations, HMIs, things like that, and there's been a lot of times where if you have to reconfigure legacy kit and there's no one around who can do it, or no one's got a clue what how his kit's even configured, I've seen that a lot as well. So it can be a bit of an arduous task doing that. And in an ideal world, if you've got an existing layer 3 gateway and you're replacing it, you'll keep the IP addresses the same. Then your clients will just work as normal. You haven't got to do any of that. Okay. So this is the transparent mode. And essentially what this is doing is it's based on the principle that we're inspecting traffic that is physically coming through the device, through the firewall. So if you look on the diagram on the left-hand side there, imagine we've got our network there at the bottom. We've got two LANs, we've got VLANs and whatnot on that switch. But if we want to talk from LAN to LAN, that has to go up to that layer 3 switch because that's the default gateway for both VLANs. So what we've done there, let's imagine that we don't have any access to that layer 3 switch. We're not allowed to touch it, can't reconfigure it, things like that. What we've done here is we've physically retrofitted a device between the switch, the core switch, and the layer 3 switch. So there's only one way that traffic can physically pass through now, and that is through that firewall. So although the clients still see the layer 3 switch as a gateway, the traffic is physically passing through that firewall. It's going in one interface, it's going out the other. And it's at that point we can then create our ACLs. We don't have to rely on the clients being, having the firewall as the default gateway. We can just write our ACLs now, knowing that that traffic has to physically go through it. So they're great for retrofit scenarios, because if you can't touch your layer 3 stuff, or you're not comfortable with it, or whatever number of reasons there may be, we can just physically fit one of these transparent mode ones and have all the same firewall functionality that we would have in a rooted mode one.
Okay. So in terms of retrofit, you could add a firewall. Do they have learning modes that would make it?
Some do, yes. I know in the Hirschmann world they make it quite easy for you, at least easier. And they do, yeah, they have a learning mode. So you essentially, it's a transparent device when you put it in learning mode. It passes all traffic through, it doesn't filter anything, but while it's doing that, it's inspecting all the connections. And after a number of hours, a number of days, or however long it may be, you've essentially got a big list of rules there, almost a baseline of a traffic that's passing through it. Now, there may still be some work involved there to kind of cut out the illegitimate connections you've got there, but it's helped you immensely with port numbers and things like that, the fundamentals of writing your ACLs. And it can be a lot of work involved in trying to find out things like port numbers, and some software packages use a great deal of them, and it can be a right headache trying to understand which ones they need. And that's where learning mode comes in. It does a lot of the hard work for you.
That's rooted and transparent mode firewalls.
Yeah. So DPI and Deep Packet Inspection, this is quite a common feature now on a lot of firewalls, particularly in kind of a Cisco world, and Checkpoint, Juniper, those kind of vendors. And it's essentially a way of inspecting the contents of a packet. So with a normal ACL, we are just filtering based on IP addresses, port numbers, that kind of thing, which is all good and well. However, the problem there is, imagine we have to write an ACL and we have to allow traffic to a web server because, we need clients to be able to read what's on the web server. The problem there is, with a traditional ACL, a traditional ACL won't care what's in that packet. So when we're talking to the web server, it just looks at the ACL, sees that it's allowed, and sends it through. But we could have all kinds of malformed and malicious data in that packet trying to exploit the web server. And a traditional firewall with ACLs won't do a thing about it. It won't be able to. It's not intelligent enough to inspect it. And that's where Deep Packet Inspection comes in. So it takes a look at the packet, takes a look at the contents, and based on a signature list or kind of heuristics type technology, it will decide whether that payload is legitimate or not, and it will pass it through or drop it. So it's taking ACLs a step further, and we've got it at the top that normal firewalls work on stateful inspection. So that's just essentially to keep track of the legitimate connections that are coming in. And that's the only way it can work with a traditional firewall. So as I say, it won't look at the contents of a packet. And that's the next step now that malicious users and hackers and people with ill intent are doing, that they know that the only way around and exploiting firewalls is through the application layer. So through the data, but the legitimate data streams they can send, i.e. to a web server, they're looking at ways to exploit that now. And that's where Deep Packet Inspection comes in.
If you're talking application layer, is there a performance consideration now? I guess you're opening packets, looking in detail.
Yes, yes. To an extent, there is, but a lot of the kind of firewalls with this functionality are doing things at line speed now, which essentially means there's kind of no latency. So the rules and the DPI functionality is kind of put into an ASIC chip. So there's no kind of, in a lot of them anyway, and there's no software lookup to delay things. So it's not as much of a concern as it used to be. Depending on, there's no right or wrong answer to it, but depending on the size of the network, the amount of requests coming in, generally speaking, you won't see too much of a delay. If you've got a line speed device, at least, anyway, and most modern ones are nowadays.
So line speed means basically that the firewall isn't impacting the speed of the network?
Exactly. It's all done in hardware, so there's no software, there's no rules to look for in software that would incur delays. So denial of service is another big kind of topic in the cybersecurity world, and it's a denial of service attack is essentially where a hacker or a malicious user will attempt to overwhelm a device in the network, or just overwhelm a network in general to a point where it can no longer process legitimate requests, and that obviously disrupts connectivity with genuine users. And that can be a disaster if you've got it in a key part of your plant or a key area of a network, and if you've got a denial of service attack going on there and legitimate requests can't come through, you may have PLCs that can't talk to each other, then it becomes a bit of a nightmare. So a lot of firewalls nowadays will also offer denial of service protection. So they will have thresholds for connection types and things like that. They'll be able to say, okay, if we've just had 100 connections fly in a millisecond, there's something not right here, and when you start throttling them back.
You've got an example?
I have a nice little example here, yeah. So the guy with the sunglasses on the top left is our hacker, and we've got our user underneath. So what's happening here is the hacker is sending, let's take TCP as an example. So with TCP, we have to establish a connection before we can send data. So we've got this SYN packet going from left to right, this SYN acknowledgement packet going from right to left, and then to complete the connection, the user on the left would send another ACK packet. And at that point, we're ready to send data, we've established a connection. And in this attack, what's happening is the user's sending lots of synchronization packets. It's trying to establish lots of connections. The device on the right is sending these SYN ACKs back, saying, okay, yeah, I'm ready to accept, just send me your final acknowledgement, but the user never does. So these half-open connections are residing in memory on your device, whether that would be a layer-free switch, a firewall, or whatever. And the more of these that we throw at this device, these half-open connections, there will eventually come to a point where the memory has been consumed, the maximum number of connections has been reached, and we've got this user on the bottom left there, sent the SYN packet, got nothing back. And that's a common denial of service type attack, and that can happen in a LAN, it can happen over the internet as well. You have these distributed denial of service attacks where a hacker will have custody of hundreds or maybe thousands of infected machines around the world, and they will send this very similar attack to this to a public server, web server, or whatever, and with the intention of bringing it down and preventing legitimate users from being able to connect.
The protection is a threshold value in there?
Exactly, yeah. With denial of service features on a firewall, they're normally quite easy in the way that you just enable it. You enable it and it does the rest. Because with a firewall that had denial of service protection, you would get so many of these synchronization packets coming in, and it would eventually get to a point it's like, right, well, I'm not going to accept any more from this user. And it will attempt to differentiate between legitimate ones and non-legitimate ones, and some vendors do that better than others. And it's like a constant battle really between vendors updating their functionality and their firmware to cope with this, and hackers trying to find ways to exploit it, I suppose.
Our final slide today on IPS and IDS, it's the final slide in one slide, but it's a massive subject.
It is, yeah.
Itself, isn't it? And it's Solutions PT, we're doing a lot of work on these systems at the moment.
Yes.
I mean, they mentioned here that they use deep packet inspection. When does it become an IDS or an IPS system rather than just a deep packet inspection firewall, or is it a bit blurred?
It's a bit blurred because there's a lot of crossover here. Some Cisco firewalls will offer deep packet inspection and IDS and IPS functionality. Having said that, you can get some devices and or software that do strictly just IDS through the use of deep packet inspection. So there's a bit of blur there, and really in the future these will be more kind of features on a firewall, if nothing else. But essentially, the difference really between the two, clues in the name, one will actively prevent it, and the other one will just detect it and be set up to alert an administrator. And they do work on the principle of using deep packet inspection, but also using like a baseline of traffic. So you may run like an IDS system for a day, a week, or however long to get a picture of how your network looks, get a picture of bandwidth being used, the amount of connections for various protocols and applications coming in and out, that kind of thing. And once you've got that baseline, then an IDS is more efficient in its ability to detect when something unusual is happening. Loads of connections coming in, lots of SNMP traffic, for example, where someone's trying to sniff a network and start to discover stuff about your devices. And obviously with an IDS system, they will alert a user. They may email a network administrator or send you a text or something like that and say, you know, there could be some potential malicious activity going on here. And obviously a prevention system will just actively start making a decision on whether it should allow or drop packets. And I think the key difference with it is that detection systems, you know, they will never drop traffic, so there's no concern for legitimate requests being dropped because your IDS wasn't quite configured right. And obviously there are scenarios where an IPS may drop traffic, but it shouldn't have done just because things don't quite look right to it. So obviously they're not 100% foolproof, but really that's the difference between the two. The IDS is almost read-only, if you will, but it will just keep you informed if anything weird's going on in your network.
And I suspect we'll be revisiting this at some point in the future.
It's a big topic, yeah.
Certainly our experience that beyond firewalls, IDS systems are what most people are looking at. And
yes.
As Solutions PT, we've been piloting 2 or 3 systems over the last few months and working with some customers, so we'll be happy to share data on that and which one we're going to go for. But yeah, there's certainly a lot more of this in the future. So thanks, Ed.
No problem.
So next time, final one on the kind of the official thing, common vulnerabilities. Just running through.
Yeah, just looking at some kind of common vulnerabilities that you may find in your network, some common ways that a hacker or malicious user may use to compromise things.
I think that'll be another great subject. Thanks, Ed.
Absolutely, no problem.
So, in terms of questions, I don't think any questions have come in, have they, during? I'll just run through this question that I mentioned earlier on, and it's actually really relevant to what we've just been talking about, Ed. And the question is, in your experience, what is the biggest challenge to implementing traffic filtering or IDS in existing industrial networks? Now, I know you've got some views on that, and so have I had. In terms of the IDS, you mentioned baselining, which is great. The baselining works fine. What I found on the projects I've been involved with is just the sheer amount of data that's produced by these IDS systems. It's almost overwhelming for the OT department. People start off with good intentions, managing the reports and the data, and they just fall into disuse. And I think that's the biggest challenge, and I think the way that we're looking to help customers with that is probably, it almost needs a managed service approach. So IDS looks great, makes a great sales brochure, but they do kick out quite a bit of stuff, even with very effective baselining.
Absolutely,
What are your thoughts, Ed, on that?
Yeah, I mean, particularly on bigger networks, there's always a lot going on when you've got a lot of you know, functionality in your network, a lot of different devices, a lot of communications between different networks. There's so much going on, and IDS, it's all dependent on how well the IDS is configured and the kind of monitoring it's been set up for. But yeah, you're absolutely right, Mike. They kick out so much data, but sometimes it's hard to differentiate between legitimate malicious attempts and normal kind of day-to-day Ethernet chatter and that kind of thing. So really, yeah, the managed service approach is generally the best way to handle it. Otherwise, it can consume a lot of your time and resources going through log files and constantly being alerted to stuff that perhaps isn't a real threat, but you may have just had an engineer on site who's loaded up a piece of SNMP software, something like that.
Another way that we are approaching this is, rather than have a managed service, we're working with some customers trialing sort of a quarterly review where we'd go in, do an IDS report. It's possible to capture the data using a PCAP file. So it can be done offline, so we can then go back and advise. That might be more realistic. So the message is really, we don't have a silver bullet today to say that's how to do it, but that's how we're approaching it, and we'll be certainly feeding back our experiences. In terms of sort of general traffic filtering, I think the biggest challenge we've come across there is getting the right firewall, especially in retrofit situations. And then you mentioned the learning mode earlier on, so we don't disrupt things.
That's right,
and testing as much as possible.
Testing, and then testing some more, because you only have to miss out one rule, one port to one device, and you can, break some serious functionality in your SCADA network. So a lot of testing has to go into it.
It's a good question because to me it just typifies the challenge that we're all hearing lots about all these fantastic things you can do, but the practicalities of implementation are not always that simple.
No, absolutely.
Okay, thanks very much. Right, well that brings to a conclusion today's webinar. I hope you enjoyed it and got something out of it. As ever, the webinars will be available for download. Myself and Ed available online, or you can call us if you've got any questions. As you know, we work with both Hirschmann and Cisco. Happy to work to assist on design and audits. As I mentioned at the start, we are starting to getting requests for us popping out and looking at customers' problems, which we're happy to do, especially if it can be flexible on timescales and so forth. We're trying to do this on a pre-sales basis. So it just remains for me to say thanks very much, Ed.
No problem, Mike.
And back here in agenda for today follows the format of recent webinars. Today looking at common vulnerabilities. Now, Ed, we decided rather than cover lots of different attacks, we would focus pretty much on two to give a more in-depth feeling of what's going on rather than do several superficially.
Yes, exactly.
So an Arp spoofing and Dhcp spoofing.
Yes.
Quick summary at the end, and then we'll take a couple of questions. So as always, just in terms of setting the scene, and I know there's a lot of regular listeners, but there are new people joining all the time. There's no getting away from the fact that Ethernet, is a very complex subject, and many of us come from more of a classic OT engineering background and not working with networking on a day-to-day basis. There's lots of training materials out there for networking and cyber, but these tend to be positioned more with the IT engineer in mind. So these webinars and pretty much all the things that we do are very much with the OT engineer in mind, and practical implementations and changes that you can do to networks to make them more robust, secure, and more available. The format of the webinars, we've been loosely following the 3-day training course that we do here at Solutions PT. And today's webinar is essentially the final in that series. But the plan is to continue with the webinars on a monthly basis. The feedback's been very positive. Thank you very much. So it was good to talk about networking, Ed. We like doing our webinars.
Of course.
So we'll continue to do the webinars as long as there's demand for them.
Yeah.
At the end of the webinar, we'll go through what the plan is for the next one. That's very much based upon the feedback that we've had, and also the things that you've picked up when delivering the training course, Ed.
Yes.
So let's dive straight in here, Ed. I'll hand over to you for a moment, if I may.
Cheers, Mike. Okay. So yeah, like Mike said, we're going to have a look, a little bit of an in-depth look at two common vulnerabilities you might find on a local area network. So generally speaking, these two attacks, they wouldn't occur remotely. This is more for if you had a rogue or malicious user physically into your network, plugged into your network. And the first one is Arp spoofing. So for those who don't know, Arp is Address Resolution Protocol, and that is a protocol that kind of maps your IP address to a MAC address and allows us to present your IP packet on a frame on your Ethernet network. So we're going to have a look at how that works and some ways that we can protect against it. The second one is Dhcp spoofing, and again, for those who don't know, Dhcp is Dynamic Host Control Protocol, and that is a protocol that allows us to automatically give out network configuration information, so allows a device to get an IP address, subnet mask, default gateway, that kind of thing. So we're going to look at how a potential spoofing attack could work there and a couple of ways that we can protect against it.
Am I right in saying, Ed, that we hear the term man-in-the-middle attacks are both of these of that category?
Exactly that, Mike, yeah. So these are essentially where basically you're not speaking to who you think you're speaking to, kind of thing. There's a malicious user between you and your destination host, whoever you're trying to speak to. There's someone in the middle, and they're intercepting your traffic and doing a numerous number of things to exploit it, essentially.
And you mentioned there, things like Arp, and going back to what I said, Ethernet is quite complex.
Yes.
We've covered these subjects before, and it's not essential to know that, but really building upon things we've done earlier, like the OSI model, understanding MAC addresses, IP addresses, and what the ARP protocol actually does.
Yes.
These are things that network engineers need to have a basic understanding.
Absolutely, yeah, because an understanding of that will help you understand how this attack can actually take place and why it's so easy for it to take place as well. So it's good background knowledge to have for sure.
Okay, so people can either revisit the early webinars.
Yes, absolutely.
Or get out a book.
Yes, all that.
Okay. So the ARP protocol.
Yeah, so ARP spoofing, how it essentially works is the nature of ARP is that generally speaking you'll have a device who needs to talk to another device via an IP address, and the only way it can do that is to learn that device's MAC address. So the source device will send out an ARP request and it will say, right, who has a MAC address for this IP address? And then the genuine device in question, the target host will say, yep, I've got the MAC address for that, here it is, it will send out the ARP reply. That will happen both ways, and you've got nice two-way traffic between A and B. Everything's all fine. The problem with that is, and the nature of the ARP protocol is it's inherently insecure, and that is because as a device, we could just send out a bunch of ARP replies. We could just say, well, actually, I am this IP address, and here's my MAC address. And there's no kind of validation or authentication. And so whoever receives that reply will, after a certain number of those replies, will just assume that to be gospel and think, oh, okay, well, I'll update my ARP cache here because I've just received a reply saying here's the new MAC address for this IP address. So it's a very easy attack for a hacker to actually undertake, and there's lots of ways that they can send out these replies. They can do it via various programming languages. There's lots of different pieces of software out there that can do this for them. And at this point, once they've sent out this ARP reply and the genuine host has received it, they'll update their ARP table, and it's at this point that that device, whenever it wants to speak to that IP address, will be sending its packets to the attacker, because as far as it's concerned, the MAC address for this IP address is actually that of the attacker. So at this point, once the genuine device has updated their ARP cache, they will send out their IP packet, they'll present it onto layer 2, they'll put the destination MAC address of the attacker. So the attacker is now receiving packets destined for an IP address that it doesn't own. At this point, the attacker, in most cases, will set up a transparent attack, and what happens there is the attacker will receive a packet, it will forward them onto the genuine destination, but it will intercept everything on the way. So the source and the destination have no idea this is going on. Unless they were to check their ARP tables and validate the MAC addresses, they wouldn't have a clue this is going on, because as far as they're concerned, normal communication is still taking place. However, the attacker is intercepting absolutely everything that's coming back and forth through them. An attacker could set this up as a non-transparent attack, and obviously what would happen there is you'd have like a mini denial of service almost. If you imagine you're a PLC trying to talk to another PLC, this attacker has sent this rogue ARP reply. The first PLC sending its packets to the attacker, but the attacker's getting them and just dropping them. And what's happening there is you've got two PLCs that can never talk to each other again, as long as you have this attacker still on the network. So there's a number of ways someone might want to do this, whether it's to steal confidential information, whether it's just cause disruption. There's a number of kind of applications for this to happen.
Okay. And there's a couple of terms that people may have heard. ARP cache poisoning, is that the same as ARP spoofing?
Yeah, exactly that, because essentially ARP spoofing is done to poison someone else's ARP cache. So it's essentially the same kind of thing, just slightly different terminology.
And gratuitous ARP always a bad thing?
Yeah, I mean, they have genuine uses in a network. If you've got a couple of redundant routers and one goes down, a backup one comes on, then it may send out a gratuitous ARP reply to say, well, I'm now the new MAC address for this virtual IP address. So there are genuine uses for it, and that's why we have it. The problem is, because of the nature of that, it's just so easy to exploit. It really is. And we'll have a look at that in the demo. So this is just a visual representation of it. We've got our switch at the top, we've got Bob in the top left, we've got Alice in the top right, and we've got our hacker on his laptop at the bottom. So you can see the IP addresses there and the MAC addresses, and your ARP cache is essentially a mapping of that IP address to a MAC address. So in a normal situation, Bob would have his ARP cache, he'd have an entry for Alice, 10.0.0.7, and he'd have a MAC address of AA, you know, all the AAs basically. And same goes for Alice. Alice would have an entry for Bob and would have a correct MAC address, and we've got a nice two-way traffic thing going on through that switch. Now, all the attacker at the bottom has to do is send out a couple of ARP replies to both of these targets, Bob and Alice, and say, well, actually, I now have the MAC address for this IP address. And essentially, both Bob and Alice will see these replies and think, oh, okay, so there's a new MAC address for Alice's IP address, and Alice will think the same for Bob. They'll update their ARP caches, and essentially what will happen then is whenever they want to speak to each other, they will present their IP packet onto the network with the destination MAC address of the hacker. So the hacker will essentially be receiving all traffic between Bob and Alice. So he'll be intercepting absolutely all of it. And in most cases, he'll just put that as transparent, so they'll still be able to talk to each other, but they won't realize that it's actually going through the attacker. The attacker's intercepting everything. And you could have, you know, critical information being passed between those two, username and passwords. It doesn't even have to be two computers we're talking about. You could have a computer and a router, a computer and a switch. So there's a number of uses this could be used for to steal passwords and login information, that kind of thing.
Okay. So maybe looking at some prevention and protection?
Yeah, so the bad news is there's no silver bullet against this, and in fact, not all vendors offer any kind of protection in terms of switch vendors. So in the Cisco world, we have this dynamic ARP inspection, and this essentially keeps a genuine mapping of MAC addresses to IP addresses. And the problem with this is there's two ways to implement it, and the first one is a lot easier, and that's if you are using a DHCP server. The DHCP server will already have a genuine mapping of IP addresses to MAC addresses because it is the server that was giving out the IP addresses in the first place. So it knows which MAC address has which genuine IP address. Now, if you don't use DHCP, then you don't have that mapping, and your only other option is to create a bunch of static entries. And now in the OT world, you've got you know, lots of networks that will stay the same for years or decades. You'll have PLCs that will sit in production, will never change. So for certain subsets of your network, it's feasible to set up this mapping, this genuine mapping of IP addresses to MAC addresses. And dynamic ARP inspection will use that mapping, and if it sees a reply from an unknown entry that's not in its table of genuine mappings, then it will drop the packet and it will prevent an ARP poisoning attack from happening. Now, the problems with that is A, the administrative overhead to implement it and manage it if you've got devices that are changing. B, your vendor may not even support it. So it's supported in the Cisco world. Other vendors like Hirschmann, I'm not entirely sure if their current release of firmware allows for this. So that's something else to consider. And really, to stop this attack from happening whatsoever, you want to prevent anyone from getting on your LAN in the first place. So we go back to your port security standards and best practices for port security, disabling ports and VLANs, that kind of thing.
And I guess this difficulty of prevention is the reason that a lot of people are looking at network monitoring now.
Yes, exactly.
Monitoring ARP traffic.
That's right.
Things like snort and intrusion detection systems.
Exactly. They will keep track of these ARP replies, and they'll be able to tell you if there's potential rogue ones. And obviously, the nature of that is you will get some false positives because, the nature of devices kind of coming and going and things changing. You may have some genuine reasons why you'd have a different MAC address for an IP address that already exists. But yeah, it certainly helps to keep an eye on this kind of thing. So we'll have a little look at a demo as to how easy it is to actually do. Okay, so we're going to have a little look here at a spoofing attack. And essentially what we've got here, this is on my laptop, I've got a virtual machine running, a Linux virtual machine, which we'll see in a second. But my laptop here, this Windows 8 installation, I'm the victim in this attack, and it will be my virtual machine who will be the hacker. So in this demonstration, we'll have a look essentially at me logging into a router and the man-in-the-middle attack kind of stealing my login information, and we'll look at how easy one of these attacks is to do. So we'll just have a quick look at my network information. So I've got an IP address there, 10.10.10.102. My gateway is 10.10.10.254, and that's my router that I'll be logging into. So first thing I'm going to do, I'm just going to ping the router, and we'll have a look in my Arp table at the MAC address of it. So everything's normal for now. I've pinged it. We'll have a look in the Arp table. Okay. So if you see there, we've got the MAC address there for 10.10.10.254, 001D, so that's like a Draytech MAC address, the beginning of one anyway. So we'll see the significance of that in a minute once we've done the attack, because that will change. So let's carry on. So that's the MAC address then for our router. And under normal conditions, when we're trying to communicate with it, that's the MAC address we'll be putting as a destination. Now this is Kali Linux. This is like this is essentially a kind of penetration testing virtual operating system built on Linux. It's got a bunch of different tools for penetration testing, I suppose, hacking, if you will. And there's a particular tool on here called Ettercap, which is what we're going to use to do this Arp Spoofing attack. So we're going to load up Ettercap. No, it's ridiculously easy to use, and this is why an attack is so easy. It's got a nice GUI. We're going to start unified sniffing, which means we're just going to start sniffing on our network adapter. We're going to scan the whole network here for hosts. This is an optional step. If you knew the IP addresses, you wouldn't need to do this. But we're just scanning the entire network for any hosts that are alive, basically, so ones that have responded to a ping. So there we've got 102, that's the victim machine, and we've got 10.254, which is our router. So we've added one to target 1, we've added one to target 2. Now what we're doing here is it's literally as simple as clicking Arp Poisoning, ticking the box for sniff remote connections, which just means we'll be intercepting and monitoring all the traffic. As soon as we click OK now, our VM will send out a bunch of ARP replies to both devices and say, well, I am now the MAC address for these two IP addresses, and both the victim machine and the router will see these replies, and it will update their Arp caches. It won't ask for validation or authentication, it will just assume that I'm a genuine user, and this is why it's so easy to do. Okay, so we've got down the bottom there, Arp Poisoning victims, group 1 and group 2. Job done. So at this point now, if I go into the victim machine here and go back on my Arp cache, and we're just going to have a quick look. Okay, so if you see there now, we've got 10.10.10.254, we've got a different MAC address now, 000C, and that is the MAC address of that Kali Linux virtual machine. So at this point, if I wanted to talk to 10.10.10.254, which is a router, I'm going to send out my frame with the destination MAC address of that virtual machine, which means I'm going to be intercepting all the traffic before I then forward it on to the genuine device. Now the only other step really here is on my Kali Linux machine is to start loading some software where I can intercept and view the traffic, and for this I'm going to use Wireshark. So this will essentially intercept all the traffic on my adapter, and it will allow me to view it, whether that be genuine traffic or this intercepted traffic as well, because it has to come through me, therefore it has to hit my adapter, therefore I can see it in Wireshark. So I'm going to load up Wireshark here. What I'll do is just put a little filter on. The problem with Wireshark, it's such a powerful tool, and there's that many packets coming in and out of your interface, but the amount of information is quite overwhelming. So being able to use filters will make life a lot easier, stops you having to sift through, loads of useless traffic you don't want to look at. So I'm going to put a little filter in here so I can only see traffic coming from the victim machine and going to the router. So I'm saying the source has got to be 102 and the destination's got to be 254. Okay, so now at this point, any traffic that goes from victim to router, I will see. So I'm now on the victim machine here, and I'm just going to log in to the router, and I'm going to send my username and password over, and we're going to see how easy that is to intercept. So this is just a Draytech router. I'm logging in here with admin username, and the password is there. Click login. Okay, and we'll just have a quick look here. You know, I can configure everything on this router. I could do a lot of damage if I was a malicious user. And essentially now at this point, because I've sent that username and password to the router, it's gone via this hacking machine, this Kali Linux machine. So we're going to try and find that now in Wireshark. Now, some vendors make it really easy for you. They'll send the username and password in plain text. Now, this attack is a lot harder to do if you're using encryption, HTTPS. There are still ways to do it. It's certainly a lot harder, and this is a big reason why you should always use HTTPS and SSH and not Telnet and HTTP for this very reason. So I'm looking here through my Wireshark logs, and I can see this traffic. This HTTP traffic is what I'm concerned with. If you see that first post there, that's me sending the username and password from the victim machine to the router, and I've intercepted it. Now, with Draytech, they try and make it slightly harder for you, so you'll notice that the username and password isn't admin and it isn't the actual password. What happens is they encode it in something called Base64, which isn't encryption as such. It's not like a one-way hash thing that we can't decrypt. It's a basic encoding and decoding algorithm. So it doesn't really make it any more secure because a Base64 decoder are available online. You could write a program to do it. There's probably a program in Kali Linux that will do it. So all we need to do is decode this thing that's been encoded by the router, and we'll see how easy that is to do. So what I'm doing is I'm copying this form item. We've got two form items, AA, AB. I'm going to assume here that AA is the username, AB is the password. There's the only two, we only sent a username and password, so most likely that's going to be the case. All I'm going to do here is go online, and I'm just going to go on Google, and I'm just going to search for a Base64 decoder. And as I say, there's 100 million websites that will do this. You could write a program to do it yourself. It's no big secret. It's by no means a secure way of transmitting data, as we'll see. I'm literally going to paste in that value there. So I'm just getting rid of this form stuff. That is our value. That's our Base64 value. I'm just going to click the decode button. And underneath, we have admin, just like that. So now we'll do the same for the password. We're going to copy that one there. And we're just going to paste that in again to the decoding website and just get rid of all this form item stuff. That's just HTML we don't need. Click decode again, and we should get our password, which is super password 101. Nice and secure. Okay, so now if we were the hacker, we've got username and password. Let's try and log into router just to verify that's actually the username and password. Here we go. Admin and super password 101, and there we go, we're logged in, and it's as easy as that. I could, as a hacker now, I could do anything I want, shut it down, make a load of changes, just cause a real nuisance, and that's how easy it is to do an Arp Spoofing attack. And as I say, with HTTPS enabled, it's a lot harder for you to get that information, that login information. So that's why it's so important to have encryption on your devices. What I'm doing here is I've disabled the attack now, I believe, in Kali Linux, and what that's done, it's reverted everything back to what it was. So I've just gone back in the Arp table there, and the entry is what it was originally before the attack. We've kind of almost wiped all traces of it happening to a certain degree, and it's that simple really, and that's why it's so important to secure devices, have secure management and that kind of thing. You want to mitigate against a really simple attack like that. Okay.
Moving on to DHCP, again, another protocol that's not inherently secure, a little bit like ARP, never designed with cyber in mind, Ed.
Yes, exactly. I think more designed for just ease of use. So, you know, a DHCP server, the server will give out your IP addresses and network information to your clients, whether them clients be PLC, HMI, a workstation, anything that supports IP will most likely support DHCP. The problem with it is when a device comes on the network and it asks for an IP address, it will just blindly ask everyone. It will just send out a layer 2 broadcast and it will say, someone give me an IP address. It won't care who, it just wants an IP address. So if you were to create a rogue DHCP server and sit on the network, you'd essentially be battling against the legitimate DHCP server, or there may not even be a DHCP server at all on the network, but you may have unconfigured devices that you can start giving out IP addresses to and therefore, you know, start communicating with.
When you say battling, it's basically who gets there first.
Essentially, yeah, and you know, there's a number of different reasons why the attacker may get there quicker than the server and vice versa. So it's by no means a guaranteed. If you are battling against another server, there's no guarantee that you will, but through, you know, exhaustive attempts, eventually you're bound to, you know, give out an IP address from your rogue server as opposed to...
Is it legal to have multiple DHCP servers on a network?
You can, there's nothing stopping you from doing it, but there's no reason why you would. Because for that very reason, you can't guarantee that the server you want to give out an IP address will. It's just going to be a game of chance, really. So, yeah, essentially what will happen there then is if you've created your rogue DHCP server, you've got a bunch of configuration details in there that you want to use to exploit your devices. That could be forcing yourself to be a default gateway, and therefore all your clients have to talk to you if they want to go out the network, rogue DNS servers for phishing attacks, that kind of thing. Or maybe you just want to disrupt devices from talking at all, and you could give out a bunch of IP addresses that don't exist in a you know, a non-usable range or things like that. So there's a number of reasons, whether it just be through disruption or through, you know, trying to steal some confidential information or whatever, that you may set one of these up.
Of course, once you're the DHCP server, you can do anything.
Exactly, yeah. I mean, you've got full control over all kinds of network information. There's so many options in DHCP, things you can give out. So yeah, if you've got one of these and you've got clients that rely on DHCP, then you can see where this can cause a lot of problems. So let's have a little look at protecting against it. I mean, this is just a basic diagram on how it would work. You've got that attacker sitting at the bottom here. Your client PC sent out his request. You've got two DHCP responses, as you can see. So really it's up to the client. Whichever one he gets first, most likely is going to use, and that could be either. But the fact is that if this device is allowed on the network, then your clients are at risk of getting a rogue IP address. So you've got, and a lot of different vendors offer something at least similar to this, and this is, we particularly talk about the Cisco world here. You've got DHCP Spoofing Protection. So you enable that on your switch, and then it's very nice and easy to configure. You basically just say, well, I want to trust this one port that's got a DHCP server connected to it, and all my other ports, I want to call them untrusted. And what that means then is if you've got an unauthorized DHCP server sending out a DHCP reply, if it's on an untrusted port, the switch will get it. It will check that it's a DHCP packet. It will see it's untrusted, and it will just drop it. So it completely prevents this kind of attack from happening. The only problem is, as I say, not all vendors may support this. And if they don't, then we're going back to either, you know, bringing in a vendor that does support it, or at least looking at your basic kind of port security standards and your best practices, that kind of thing.
Okay, so a question I've asked you a number of times over the webinar, Ed, you know, OT engineers, is this something that really they should be aware of, or at least know how their network's set up in this respect, things like how it would handle the ARP and DHCP situation?
Yeah, absolutely. Particularly the ARP one, the ARP spoofing attack has so many uses, so many practical uses an attacker may want kind of to do with it. And it's very risky, and the things you can, you know, do with it, and we've seen how easy it is to do. So in particular that, it's good to have an understanding as to how it works and how you can stop it from happening, or at least stop it from causing, you know, a lot of disruption. So your real key areas of your network, I suppose, where you want to be looking to protect against that. And that's where things like VLANs come in. If you've got, you know, a bunch of different VLANs, you've got total control over which ports on which VLANs. You've completely locked them down from a physical point of view. assuming all your switches are in, a secure area, physically locked cabinet, things like that. No one can even get on that VLAN to cause, this disruption and to...
The attacks we talked about today are very much assuming someone's got access to your network.
In most cases, yes, in most cases, yeah.
Yeah, it is not to let them get there.
Exactly, yeah, that's why physical protection on your network is one of the most important things. You don't want people just coming along and plugging into a switch port.
Thanks, Ed. Really interesting. And some of the tips you gave on the video there, really useful. And again, that builds on things that we've covered earlier on.
Excellent.
I mentioned at the start about the next webinar, and we've picked a subject. We're going to do a deeper dive on something we covered in the first webinar, and it's IP addressing and subnetting, Ed. This is based on feedback from people on the webinar saying what help they'd like. It's also based on our experiences that this is certainly the biggest reason for downtime, availability problems on networks.
Yes.
It's quite a dry subject, and what we're going to try and do is maybe send out some information in advance to people that register for the webinar, maybe some addressing examples, and we'll go through those examples on the webinar.
Yeah.
So your challenge, Ed, is to make subnetting and addressing
interesting. Yeah, I'm not sure if that's possible, but I'll give it a try, yeah.
We'll give it a go.
Okay.
So in terms of questions, a question came up on today's webinar, and you mentioned VLANs there. And I think the question was about if you got your VLAN set up correctly.
Yeah, I mean, you can't really do an ARP spoofing attack from one VLAN to the other, unless you spoof the layer 3 interface. That's probably a topic for another day, but certainly it mitigates it a hell of a lot. And that's why VLANs are so important. Your key devices you want in a secure, separated VLAN that has got physical security. You haven't got a bunch of unused ports in that VLAN. So you've really locked that down and you're controlling it to the point where no one can even get onto the network to do this kind of thing. So yeah, this is why VLANs are so important, not just from a segregation point of view, but from security for this very reason.
And I know that you almost dedicate the whole day to VLANing on the training course.
Yeah, more or less, yes. It is a big topic, and perhaps it's one we can look at a bit, in more depth on one of the webinars in the future.
Thanks, Ed. I appreciate it today.
No problem.
So there's a slide here on more information. Please continue to download the webinars. I think as we're doing more and more, we're going to put a bit of an index on there to make it easier to find them. So it just remains for me to say thank you very much for your time today, and we look forward to chatting again on the next webinar. Thank you. Bye-bye.
Cool. Bye-bye.